Hi guys, my name is Ryan Fossil and I am a computer science student at Georgia Institute of Technology, and I have a CS background, but unfortunately I don't really have a circuits background. So when I got into the Arduino and Parallax and all that other sort of microcontroller stuff, I found the coding pretty easy, but I was having a hard time with these circuits because, they weren't as simple as they seemed. So this kind of prompted me to go and learn some of these electrical concepts that I had never heard of before. And I would like to take the opportunity to try to share them with you guys in a not too complicated fashion so you guys can get the basics too. I'm going to try to keep this as quick as possible, and this is my first video, so in the comments you can tell me how bad it sucks, how good it was, where I can improve on, but I'm going to try my best. So today we're going to explore voltage dividers. So in a circuit you have a power source, and I'm not saying that these are the official engineering symbols either. I think they're close, but they're definitely not right. So you have a battery, and we're going to say that battery is 9 volts. And we have the circuit, and this is the symbol for resistors. There are resistors coming around up here. Boom. Okay, we're going to say that this resistor has a 500 ohm resistance. And we're going to say that this has a 100 ohm resistance. So what we want to do is figure out what the voltage is right here before it gets to the second resistor, but after it's gone through the first resistor. So we want to figure out what the voltage is right here. So what we're going to do is we're going to take the whole circuit, and I want to take a second to explain what it means that the battery is 9 volts. What that means is when the electricity starts here, it's at 9 volts. That's a little oversimplified, but you can just say it's at 9 volts. By the time it goes all around these circuits, and these resistors are considered loads, which means that they use up voltage. By the time they go through both these resistors and get back to the negative edge, it's at 0 volts. So 9 volts means that from the positive side to the negative side, you have lost 9 volts, or a voltage drop of 9 volts has occurred. So that's what that means when someone says that the battery is 9 volts. It means that from here to here, there's a difference of 9 volts. Okay, easy enough. So what we're going to do first is look at the circuit from a macro standpoint. So the whole circuit. So we're going to use this equation, which I'm sure you've seen lots of people use in the past, and I'm going to try to cram it on this page so that you can see it all together. So hold on, let me erase this. And so, just so you guys don't lose reference, we're going to say this was 500 ohms. Ohms is a measure of resistance, just in case that was not known. Okay, cool. We have this formula called V equals IR, and it's super handy. How it works is V stands for voltage, I stands for current, which is usually measured in amps, that's probably where you've heard it, and resistance, which is usually measured in ohms. Okay, cool. So, we're going to look at the whole circuit. The whole circuit has a 9 volt drop. We don't know the current. There's no way we can tell the current. However, the total resistance of the circuit is 600 ohms because we had 500 ohms here and 100 ohms here. So, if we do that math, which, hold on, you get, I believe this is right, I hope my math is right, or I'm going to feel like an idiot, 15 milliamps, or what you probably got on the calculator was 0.15, 15 milliamps. Okie dokie. So this whole circuit is in what's called series, meaning that if we forget about this part, the whole circuit is in series, which means that the amperage has to be constant throughout the whole circuit. Because think of it, amperage is how fast the electrons are traveling through the wire. So if they're going in single file line, that means that throughout the whole circuit, the electrons have to be moving at the same speed, or else they'd bump into each other. That's probably a little oversimplified, but that's how I see it in my head. So, therefore, we know that the amperage of the current of the whole circuit is 15 milliamps. Cool, that's good to know. So now, what we want to do is figure out what is the voltage drop over this resistor. So what's the voltage here, what's the voltage here, and how much did it change? Well, you can use V equals IR to do that same exact thing. So let's say we do V equals IR. What we're doing now is, instead of seeing the whole circuit as a macro sort of thing, we're now just looking at the circuit being from here to here. Also probably oversimplified, but it makes for a really good analogy. You're looking just from here to here. So what do we know over that? We have no idea what the voltage drop is, because we just don't know. But we know that the whole circuit has a 15 milliamp current. So we know that, and we also know that the resistance over that resistor is 500 ohms. So if we do that math, we get a voltage of 7.5, which means that the voltage drop is 7.5 over this resistor. Now we're kind of running out of room, so let's go to the next page. Now we're going to do the same exact thing. Okay, let's write this down for a reference. First resistor was 7.5 volts of drop. Now we need to find out what the second resistor is. We don't need to figure it out to get that middle line that we're measuring, but let's do it for the hell of it. So V equals IR again, our friend, our returning friend. We have no idea what the voltage is, but we remember that the whole circuit has a 15 milliamp current. And then we know that we had a 100 ohm resistance across that second resistor. So if we do that math in our head, then we get a number that I'm going to look up on a calculator. Hold on. Then we get 1.5 volts, which, for those of you that are clever enough, realize that, let's look at this, the total circuit was 9 volts. 9 volts, and the first resistor was 7.5. So if you subtract that and take 2 and you subtract 1.5, you get 0. All that to say that these two numbers, which make up the circuits, the two loads, added up to 9 volts. So that's a good way to check yourself. The total circuit should be equal to the total amount of voltage drop across the circuit, because that's essentially what the volts are. So that's all good and well, but right now that's just math. Why the heck is that useful to us? Well, I'm going to show you a time when that is useful for you, and this is one thing a voltage divider is used for. And one thing before we go on, let's change colors to make it interesting. One thing I'll say before we move on is that if you have something that needs 5 volts of power and you have a 12 volt source, this method of a voltage divider would probably work, but it's not recommended because this is kind of a rough estimate, and for reasons that are beyond my understanding, it's just not always the most trustworthy constant source of the same amount of voltage. So you're better off getting a voltage regulator, something like that. I think it's 7803 or 7805 is what they're at Radio Shack. That's a much better way of doing a power source. So I'm about to show you why this is useful to you and why you would ever want to have a voltage divider in your circuit, especially as pertains to an Arduino. So let's see, we have our battery. That was a bad drawing, 9 volts. And then we got our circuit, our resistor. That was a really bad resistor. That resistor probably doesn't work well. There we go. Not much better. 500 ohms, 100 ohms, and then we have this line, which let's say it's going to an Arduino pin, and I forget if it's AR or AD, so I'm just going to call it the IRDUINO. To Arduino, let's go say that goes to one of the analog pins on the Arduino, which if you don't know, the Arduino analog pins, I think, can take up to 5 volts. and measure and give a reading as to how many volts are going through that pin, which check on the specs because I know they can only handle up to so much voltage, and I didn't account for that in here, but because I think it can only hold 5 volts. But anyway, I'm rambling. You might want to send the voltage, whatever it is after this first voltage drop, but without taking into consideration the second voltage drop, and send it to the Arduino. Now you're probably saying, Ryan, it's going to be the same. How does that help you? You're going to be measuring the same exact voltage the whole time. Well, yes, that's true, but what if right here, instead of having a 100 ohm resistor, you had a variable resistor whose resistance was constantly changing? A real life example of that is a photoresistor, so photoresistor. So a photoresistor changes its resistance depending on how much light it's getting. So for our example, we're going to say more light equals more resistance. So let's say we have lots and lots and lots of light in our circuit because we want to measure the light. And we're going to say this is a huge number, like 1,000 or 100,000 ohms. If this number is really, 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 really high, especially as compared to this number, like 100,000 ohms is much bigger than 500 ohms. That means that when you go back and redo your math for the whole circuit, you're going to realize that across this resistor, a majority of the voltage drop occurs because it's got the highest resistance. So that means almost no voltage is going to get dropped along this resistor. And I know that's kind of hard to understand, you got to take my word for it. You can go back and work the math and see how when one resistor is higher than the other, how that affects voltage drop. But if the second resistor has a lot higher resistance, it's going to have a lot higher voltage drop. So basically what that means is, let's say the voltage drop across this was just 1 volt. I haven't checked. This is just, let's say it was 1 volt. And it's a 9 volt battery, then going to the analog pin is only going to be 8 volts. And so your code could say, when the voltage that I'm measuring on my analog pin is high, do this action. Maybe like close the blinds so it gets darker. But let's say at night we have less light, obviously means, yep, you got it, less resistance. Let's say this was down to a meager 5 ohms. Well, now 500 ohms is way bigger than 5 ohms, so majority of the voltage drop is going to occur over this resistor. So now if we redo our math, this might do with 6 volts of drop across this resistor. So now, what's going to the Arduino is, let's make some space, to the Arduino, you're dropping 6 volts. There's only 3 volts available after going through this resistor that is going to the Arduino. So, to Arduino. So in your code, you might say when the number is less than 4 volts coming to here, open up the blinds because it's too dark in here. Or I guess if it's a night, turn on a lamp, and then it will get lighter in the room. So this really comes into use. Let's do a recap. This comes into use when you have a variable resistor that changes. It tells you how you can interpret the voltage drop across the 2 resistors and how you can use that in your code. And you'll see examples of this on the internet. A voltage divider is extremely helpful for measuring things like this. Because, let me just show you one more thing. If you only had 1 resistor in your whole circuit, then all the voltage is going to drop over that resistor. So if you had a 100 ohm resistor, or you had a 2000 ohm resistor, or even if you had a 1 million ohm resistor right here, the drop, and you had a 9 volt battery, the drop is always going to be 9 volts over that resistor because it's the only load on the circuit. The only thing that's going to change when you do your resistance is the amperage going through the whole circuit, because V equals IR, Wow, that was bad. V equals IR. The resistance is staying the same no matter what. I mean, if you add resistance to the circuit, then it's just going to make the I go up or down. But when you have two resistors in the circuit, you can basically control the voltage between the two resistors depending on what the two values of the resistors are. So that's the end of my lesson, and thank you for watching, and I hope that this made sense to you guys. I hope that I did an alright job explaining it. It's my first tutorial, and voltage dividers, I'm trying to make an easy explanation, and I really hope it helped. Please feel free to leave comments on this video, and I hope it helped, and you guys have a wonderful afternoon. Anyway, bye.
Made with Doodlecast Pro.